We spend a lot of time talking about what our devices can see and hear, but what if they were about to get a brand new sense? We're talking about the ability to smell. Today, we're diving into the incredible science of digital olfaction.
Just let that sink in for a second. We totally take our phone's camera and microphone for granted, right? But imagine that same little device in your pocket, being able to sense the world through all the invisible chemical signals that are floating around us all the time. It sounds like science fiction, but it's way closer to being a reality than you might think.
And look, this isn't just about your phone knowing you brewed a pot of coffee. The real game-changing promise here is its potential to become this incredible non-invasive tool for our health, to literally detect changes happening inside our bodies long before we ever feel a single symptom.
So, the big question is, how is any of this even possible? Let's get into the core idea behind this amazing technology. Okay, so at its heart, a digital nose, or what scientists call an e-nose, is really just an attempt to build a synthetic version of our own biology. It's a combination of two things: hardware, a bunch of tiny chemical sensors, and really powerful AI software. The sensors detect odors, and the AI figures out what they are. It's basically mimicking the partnership between your own nose and your brain. Now, to build a great artificial nose, scientists first had to really understand the natural masterpiece they were trying to copy. So, how does our own sense of smell actually work? It's an unbelievably complex and sensitive system. See, when you smell something, these tiny molecules fly into your nose and hit millions of receptors. But what's really fascinating is that it's not like one receptor equals one smell. Instead, every single odor creates a unique pattern across thousands of these receptors. It's like a barcode. That barcode gets sent to your brain, and your brain instantly decodes it as, oh, that's freshly cut grass, or that's bacon.
But, for all its brilliance, our biological nose has its limits. Our perception of smell is pretty subjective. And you know how you stop noticing a smell after you've been around it for a while? That's called olfactory fatigue. But most importantly, we just can't smell a lot of really important things, like carbon monoxide or the specific chemical markers for a disease. And that's the gap a digital nose is designed to fill.
So, if we were going to build an electronic nose from scratch, what would we need? Let's look at the nuts and bolts that make this whole thing work. It's really a three-step process that beautifully mirrors our own biology. First, you have the sensor array. That's the artificial nose. Its job is to detect airborne chemicals called volatile organic compounds, or VOCs. These are just the tiny molecules that everything from coffee to flowers to even our own bodies release into the air. Second, all that raw data gets processed. Think of this as the signals traveling through our nerves. And finally, the AI brain analyzes that data to recognize the unique smell print and tell you what it is. Now, there isn't one single perfect sensor for this job. It's more like a toolbox, where each tool is specialized for a different task. For instance, metal oxide sensors are super sensitive, but they're power hogs. Conductive polymers, on the other hand, sip power, but they can get thrown off by humidity. That's why the secret sauce is often using an array of different kinds of sensors so you can combine all their strengths to get the clearest possible picture of a smell. Okay, this is where it gets really good. This is where the theory hits the real world. What can we actually do with a device that can smell with this kind of superhuman precision? Well, the impact on medicine alone could be absolutely revolutionary. Our breath contains thousands of different chemicals that are byproducts of what's happening in our bodies. By analyzing these, an e-nose could potentially sniff out the unique chemical signatures of diseases like lung cancer or diabetes or even infections long before traditional symptoms ever show up. It's basically the ultimate early warning system. And the uses go way beyond medicine and into our everyday lives. I mean, imagine a sensor in your fridge that tells you your milk is about to go bad, cutting down on food waste. Or a device that can instantly tell you if that expensive bottle of olive oil is actually the real deal. From monitoring air pollution across an entire city to detecting a dangerous gas leak in your home, the impact on safety and quality control is just huge. This all sounds pretty amazing, right? And it is. But if the tech is so promising, why don't we all have smell sensors in our phones already? Well, as you can imagine, there are some pretty big hurdles that scientists are still working hard to clear. So what are the key technical challenges that are standing in the way of this revolution? There are a few big ones. First, sensors can drift. That means their accuracy fades over time, kind of like a guitar going out of tune. They can also get really confused by simple changes in humidity or temperature. And then there's the complexity problem. A real-world smell isn't just one thing. It's this messy cocktail of hundreds of different compounds. Teaching an AI to untangle all of that is incredibly hard. And finally, just cramming all this sophisticated tech into a tiny, power-efficient chip that can fit in your phone, that's a massive engineering puzzle. But here's the thing, while the challenges are very real, the pace of innovation to solve them is just incredible. The future of digital smell is quite literally in the air.
So this is where we're heading. Researchers are using amazing new nanomaterials, like graphene, to build sensors that are thousands of times more sensitive than what we have today. They're creating what are called biomimetic sensors, which are basically direct copies of our own biological receptors. And they're developing super-efficient AI that can run right on the device itself, no cloud needed, making real-time analysis possible in small wearable gadgets like a smartwatch.
When you boil it all down, it comes to this. The idea of your phone being able to diagnose an illness just by analyzing your breath, well, that's moving from the world of science fiction to becoming an imminent reality. It really represents a fundamental shift toward a more proactive, preventative kind of healthcare. So I'll just leave you with this question to think about. We learn to see the microscopic world with microscopes and the cosmic world with telescopes. When we finally give our devices a sense of smell that's far beyond our own, what new, invisible worlds are we going to discover all around us?